Security is an important aspect of any network infrastructure. We will today focus on a critical area of network security by examining a type of attack frequently observed in internal networks, the MAC flooding attack. First, let us understand the MAC flooding attack. We will explore the functionality of MAC flooding attack and the necessary steps to mitigate it using the switch port security feature. The MAC flooding attack targets layer 2 of the OSI model, specifically the data link layer. The primary goal is to overflow the switch MAC table or the CAM table, the content addressable memory table. A switch standard operation involves inspecting every incoming Ethernet frame and learning the source MAC address from it. It then maps this MAC address to the specific port it was received on and store this mapping in the CAM table. The CAM table is distinct from standard memory like RAM because of the difference in speeds. Unlike standard memory, which is addressed by location and requires a sequential lookup, content addressable memory or CAM is addressed by the content. So this means the switch can simultaneously search its entire table for a matching destination MAC address within a single clock cycle. So this is crucial for achieving high speed and low latency as it prevents any delay in the data transmission, because the switch may receive hundreds or thousands of packets in a second. So latency is very important. This low latency or efficiency allows the switch to rapidly forward future frames destined for the MAC address only to the correct port, preventing unnecessary data flooding across the network. This process ensures that data is forwarded only to the intended recipient, maintaining confidentiality. However, a critical vulnerability arises when the CAM table becomes full. When the table overflows, the switch is forced into a fail open mode. In this mode, instead of unicasting, the switch begins to behave like a network hub, resorting to flooding all incoming data traffic out of every port. This happens because the switch can no longer learn or look up new destination MAC addresses because the table is already full. It cannot store any new MAC addresses, which helps the attacker connected to any port on the switch to eavesdrop on all the network communication, including the confidential data exchanges between other devices. This is a significant security breach. To understand the attack, we use a minimal network topology focusing on client server confidentiality. We will use a device switch S0. So let us choose an in device switch 2901. Sorry, choose a switch 2960. This will be our central device, and we will connect a client on one side of this switch and server on other side of the switch. So we make use of two interfaces on the switch to connect this client and server. So this client PC is a normal standard PC and the server is the standard server device. Next we use an attacker's device, a standard router. Select a router 2901 for instance. And then now we will connect all these devices. Choose the router's gigabit Ethernet 00. to the switch fast Ethernet 00. Then PC's fast Ethernet 0 to the switch fast Ethernet 02. Then switch FA03 to the server's fast Ethernet 0. We will assume a scenario where the client PC0 sends a request to the server for confidential data. The server responds to the request, sending the data back through the switch 0. An attacker connected via router R0 to the switch router 1 attempts to intercept the server's response. So let us make the initial configuration before we simulate the attack. So the router's gigabit Ethernet 00 is connected to the switch fast Ethernet 01. PC0 fast Ethernet connected to the switch fast Ethernet 02. Server's fast Ethernet connected to switch fast Ethernet 03. The network uh, we use the network address 192.168.10.0. 192.168.10.0. Now let us start by uh, giving a valid IP address for all the end devices, starting with the server. Configure, desktop IP configuration. Let us use the first usable IP address 192.168.10.1 for the server, and for the PC 192.168.10.2, and for the router's gigabit Ethernet enable configure terminal, then select the interface gigabit Ethernet 00, then give it a valid IP address 192.168.10.3, subnet mask 255.255.255.0. Try to bring it up. Let us wait for the interface to come up. Yes, all the interfaces are now up. So let us confirm the connectivity between the devices by running a ping command. Before we run the ping command, let us see what is there in the MAC table of the switch initially. Show MAC address table. So you can see the MAC address table is now empty. There are no entries in the MAC address table. Now let us ping the device. From the router, let us ping the server 192.168.10.1. See, the ping is successful. The router is able to reach the server. So does PC. We will now see what are the updates in the MAC table. So you can see 6301 is the MAC address. So you can verify it. 6301 is the MAC address of the router. So let us copy this. Similarly, let us also verify what is the MAC address on the PC. So this is the MAC address on the PC. 51BA, copy this. Similarly, let us also see what is the MAC address on the server. C39C. So these are the MAC addresses on all three devices. Now let us go back to the server switch and see 6301 is the MAC address connected to the port FA01 on the switch. FA03 is connected to C39C. So the switch has learned these MAC addresses from the ICMP message or the ping message from router to the server and the response from server to the router. Now let us simulate the MAC flooding attack. So in a real world scenario, specialized tools are used to rapidly send frames with random source MAC addresses. However, in simulation environments like Cisco Packet Tracer, we use a device such as router to send many unique MAC addresses to the switch interface, here FA01. The attacker changes the router's interface MAC address repeatedly. So you can pick the router, open the CLI. We are already on the interface gigabit Ethernet 00. Now I'll change the MAC address to copy, paste. So the 6301 was the actual MAC address. Now I'll change it to 6302. Also let us give new MAC addresses repeatedly: 6303, 6304, 6305, 06, 07, and so on. Now let us go back to the switch and see what happens to the MAC table. See, on the same interface FA01, there are so many MAC addresses that were learned. So this is the simulation of a MAC flooding attack where multiple packets with random MAC addresses will be forwarded to the switch, making its MAC table overflow and then making it not able to read any new MAC addresses or store any new MAC addresses. Once the CAM table is full or the MAC table is full, the switch can no longer recognize the destination device PC0 or learn its MAC address. So when the server's response reaches the switch checks the destination MAC address. Since it cannot find the address in the CAM table, it starts to broadcast the incoming data from the server. The data is forwarded out of all ports, including the interface connected to the attacker's router R0. The attacker successfully captures the confidential data, compromising security. So with the CAM table full, the switch cannot record the location of the new destination MAC addresses. So any subsequent frames will have to be broadcasted instead of being forwarded to the destination. So this is a significant security threat. So now let us try to mitigate the MAC flooding attack using port security feature on the switch. To defend against MAC flooding attacks, port security is the recommended defense mechanism. This feature restricts the maximum number of allowed MAC addresses on a single switch port. It is a three-step process. The port security is typically configured on the relevant switch interface, in this case the fast Ethernet 01. First, let us enter the global configuration mode, then select the interface FA01. and then set the switch port to access mode. Now we will enable the port security and define the maximum allowed number of MAC addresses. We will restrict the count to a small value, for example, 3 or 2. This is a standard practice. So we'll enable the port security feature, switch port security, and then set the maximum limit to 2. Then specify the action the switch should take when the MAC address limit is reached or exceeded. Shutdown option is the most secured option. So you can run the command switch port security violation shutdown. A sticky feature is often configured to dynamically learn and permanently store the first allowed MAC address. So to enable the sticky feature, run the command switch port security MAC address sticky. So this will allow the switch to learn only one MAC address dynamically and store it permanently in the MAC table. So when the shutdown violation action is triggered, the switch administratively disables the port or puts it in the error disabled state. To restore the service, the administrator must manually intervene with a two-step process. First, we will have to disable the interface and re-enable the interface later. So now let us simulate the MAC flooding attack. We will introduce two PCs, PC1 and PC2. Let us give a valid IP address for them on the same network. 192.168.10.11 for PC1 and 10.12 for PC2. Let us also copy the MAC address of them. 3B42 for PC2 and double B1D for PC1. Okay. So now let us go back to the switch. Check the MAC address table. Now let us flood the MAC table with random MAC addresses. So I'll go to the router, select the gigabit Ethernet 00, and then start giving unique MAC addresses. See, the switch have now administratively changed the status of the interface to down because of the security violation. Now if I pick this interface up and then connect the interface to a PC on the same network, still this interface will remain administratively down. Now to restore the service, the administrator must run the command. See, you can see the interface status have changed to down. You can see the running configuration on the switch. So running configuration. See, the sticky feature allows the router to learn only a limited number of MAC addresses on the interface FA01. However, the security feature is not enabled on the remaining interfaces. You can also notice the interface port security. Sorry, show port security on the interface FA01, and the port status is now secure shutdown because of the violation, port security violation. The port security is now enabled. So to bring this up again, let us run the command. Let us first disable it, shutdown. Sorry, select the interface in the configuration terminal. Then shutdown. Now the state of the interface is administratively down. To bring it up, let us run the command no shut. See, the interface has now come up. Wait for the interface to come up, and then you can run the ping command. Desktop command prompt ping 192.168.10.1, the server's IP address. See, the interface is now up. Now shutdown is not the only option for the switch upon port security violation. There are two other options for the switch which are less secure. The restrict mode drops packets from unknown sources when the MAC limit is reached. It will not shut down the port entirely, it will only drop the packet from unknown sources. So for that, the port security, sorry, switch port security violation restrict. Now you can see the port security on the fast Ethernet. So the violation mode is now restrict. So if a security violation happens, the link won't be administratively set to down automatically. Anyhow, new addresses won't be learned by the switch. Also, any new source MAC, any new frame with a unique MAC address will not be forwarded. It will be simply dropped. The third option is the protect mode. Protect mode is the least secured option. It also drops packets from unknown sources but does not provide any alert. So we will go back to the router connected to the gigabit Ethernet. Wait for the interface to come up. We will repeat the MAC flooding attack. See, even after changing the MAC addresses more than two MAC addresses, the interface still remains up. It will not be shut down. Then the third option is the protected mode. Select the interface FA01 and then set the port security violation to protect. So the switch, upon detecting a security violation, will simply drop the packets that violate the limit. Also, it does not generate a log message and does not increment the violation counter. The administrator has no automated notification of the attack. So this is the least secured uh, violation action. The MAC flooding attack exploits a fundamental weakness in a switch operation by overflowing the CAM table. By implementing the port security feature with a strict MAC address limit and selecting an appropriate violation action, with shutdown being the most secure, administrators can decisively mitigate this threat and manage port violations, ensuring adequate security. Thank you.